Good morning, all of you. Hope you are doing well. Let's see. Come on, join first. After that, we'll start our class. Come on, come on. Come on, join first. Yes, I can see. Good morning, good morning, good morning. Good morning. Good morning, all of you. Good morning, all of you. Good morning, all of you. Come on, fast, 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 fast. Join first so that we can start our class. Come on, fast, 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 fast. Come on. Not even half of the students are joined. Not even half of the students are joined. Not even half of the students are joined. Come on, fast, fast, fast. Not even half of the students are joined. Yes, I can see not even half of the students are joined. Where are the others? Are they sleeping? Are they sleeping? I will take the attendance also today. Today the attendance will be taken. I'll take the attendance also. Not even half of the students are joined. Okay. Yes, not even half of the students are joined. Where the rest? Rest are sleeping. Rest are sleeping. I'll take the attendance also today. Today the attendance will be taken. Yes, Ankur Pali says, sir, very hot. We could not sleep. Yes, it was very hot yesterday. Yesterday it was very hot. We could not sleep. That's correct. That's correct. Uh, let's start the portion. Uh, let's start the portion that uh, in our last physics class. Last physics class, I think I told you your marks and we discussed about the question answer of your UT. And before that, we discussed, before that, I told you to watch two videos. Those two videos you have already watched before your UT. Two videos was about density and relative density of liquid and solid. How will you find the relative density and density of solid and density of liquid? This portion is very important. Okay, and this portion is a little bit complicated also. No, the relative density of solid and relative density of liquid. There are different formula were there, and I discussed all those formula. In those videos, two videos. I told you to see those videos in our last class. I don't know how many of you have watched those videos, but I told you to watch it. Okay. Now, all of you get ready with your physics copy with you, physics notebook. All of you get ready the physics notebook with you. We will write something on that. First, we have to finish this chapter. Then we'll move to say next chapter next day. All of you get ready with your physics copy, physics notebook with you. I will tell you to write something. First. And I can see not even half of the students are joined. Not even half of the students are joined, I can see. And rest all are, I don't know where are they. But the attendance will be taken today. And those who are absent, I will send their name in your group. Okay. So I hope you are ready with your physics notebook. I mean your physics copy. We will write something. First we'll write the formula. This formula we already discussed in our videos. Last physics class, I told you to watch 2 videos. Those 2 videos you already watched uh, before your UT. Yes, before your UT, you already watched those videos. And in those videos, we discussed about density. What is density? Here, just we'll discuss the formula, nothing else. Sir, my copy is finished. I am doing a new copy. Okay, no problem. Your copy is finished. Okay. Samriddha, yeah, doing new copy, no problem. But keep all those copies safely with you. Okay. Keep all those copies safely with you. Acha. Now, uh, the thing is that now we'll write the formula, some formula. Okay. These formulas are important. First of all, density. You know the formula of density? Density equal to mass by volume. Write it. All the formula will write. Write density equal to mass by volume. Write it. Now write CGS unit of density is CGS unit of density is gram per centimeter cube. Gram per centimeter cube. Okay. In the next line you write, SI unit of density is kg per meter cube. Kg per meter cube. All of you wrote, or do I have to repeat? I'm sure I don't have to repeat because I hope you have written it. Okay. Do I have to repeat? Okay. So density is done. Density is done. Fine. Sagnik has said done. Done, Sagnik. Density is okay. Now, next line you write relative density equal to, right? Relative density equal to density of the solid by density of water. Okay, density of water at 4 degrees Celsius. You can write that at 4 degrees Celsius. Density of the solid by density of water at 4 degrees Celsius. Okay. Next line you write. Next line. Relative density equal to mass of the solid. Mass of the solid of certain volume. Of certain, CERTAIN, mass of the solid of certain volume by mass of water. Mass of water at 4 degrees Celsius. Mass of water at 4 degrees Celsius of equal volume. Of equal volume. Okay. Next line you write relative density equal to relative density equal to relative density equal to weight of the object in air. Weight of the object in air, 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 by weight of the object in air. Again, weight of the object in air by weight of the object in air minus weight of the object in water. Okay. Relative density equal to weight of the object in air by weight of the object in air minus weight of the object in water. Okay. Next formula. Next formula. Remember all this. Okay, Ankurpal is saying to repeat this last formula. Last formula I am repeating. Relative density. Relative density equal to weight of the object in air by weight of the object in air minus weight of the object in water. Weight of the object in air by weight of the object in air minus weight of the object in water. Next formula. Next formula. Next formula. Relative density equal to next formula. Relative density equal to, listen very carefully. Relative density equal to weight of the object in air, right? Weight of the object in air by weight of the object in air, again, weight of the object in air minus weight of the object in a liquid, not water. Weight of the object in a liquid. Understood? Wait, I'm writing it. You are getting confused, I think. Let me write it for you. I will show you what I've written. Relative density equal to weight in air by weight in air minus weight in liquid. Say, oh, it's visible. Is it visible? Is it visible? Okay, then write relative density equal to weight in air by weight in air minus weight in liquid into relative density of liquid. See, relative density equal to weight in air by weight in air minus weight in liquid, not water. We are not writing water here. Weight in liquid. But in that case, into relative density of liquid we have to write. Relative density of liquid we have to write. Okay. Remember, this is relative density of liquid into relative density of liquid. We have to write. Write it. So relative density equal to weight in air by weight in air minus weight in liquid. Not weight in air, weight in liquid into relative density of liquid. Okay, this is another formula. Now, so whatever we discussed, how many formula we discussed? I think 5 or 6 formula. Okay, all these formula are for solid. Okay, all these formula are for solid. Okay, to find the relative density of solid, all this formula. Fine. Now we will discuss one formula. Yeah, 5. Okay, 4 or 5 formula, whatever. But all this formula were for solid. You have to remember this formula for solid. Now we will discuss. All the formula for liquid. But just for liquid, we'll learn only one formula. That's enough. For liquid, we will remember only one formula. So how to find the relative density of a liquid? To find the relative density of a liquid, I made a video, and I told you to watch that video before UT, and after UT also I asked you to see that video. You might have seen that. In that video, I discussed one formula to find the relative density of liquid. Okay, write that formula. Relative density of a liquid equal to relative density of a liquid equal to weight of a object in air, weight of an object in air minus weight of the object in liquid by weight of the object in air minus weight of the object in liquid. Understood? Or should I write it for you? This is the formula to find the relative density of liquid. Relative density equal to of the object in air. This is the second formula. Second formula. This one. This one. Relative density of liquid. This is the formula to find the relative density of a liquid. Okay. To find the relative density of liquid, weight of the object in air minus weight of the object in liquid. The liquid whose relative density you want to find. Understood? The liquid mentioned is the relative density you want to find. So weight of the object in air minus weight of the object in liquid by weight of the object in air minus weight of the object in water. Understood? This is the formula to find the relative density of any liquid. Okay? And now, one more thing. The CGS and SI unit of density, I told you, CGS unit is gram per centimeter cube. Density. Okay, density. CGS unit is gram per centimeter cube and SI unit is, yes, kg per meter cube. Okay. But relative density does not have any unit. Relative density is a ratio. Okay, it does not have any unit. So write this note, because if in the exam, if it comes, what is the unit of relative density, and you will say nothing, then they will ask you why. So what should be the answer? Right. Since relative density is just just a ratio, since relative density is just a ratio, since relative density is just a ratio, hence it does not have any unit. Okay, it does not have any unit. Understood? Now the formula are ready with you. We'll do numericals now. Okay, the formulas are ready with you now, so we'll do numerical. Fine. So all of you write the numerical. I will read it out for you. You write it. Write the question first, then you solve. Numericals. Right. The weight of a solid, the weight of a solid in air, the weight of a solid in air is 60 gf. 60 gf. Okay, 60 gf. And what you have written, the weight of an object in air is 60 gf, and in in water is in water is 50 gf. Fine. I repeat, the weight of an object in air is 60 gf, 60 gf, and the and in water is 50 gf, 50, 50 gf. Find find the upthrust. Find the upthrust and the relative density of that object. Find the upthrust and the relative density of that object. Okay, find the upthrust and relative density of that object. Now you solve this sum. Upthrust and relative density. You solve this sum and write the answer in the comment. Let's see. All the formula I've given you, and upthrust you know. I gave you the concept before. That day also, last class, I told you to watch the two videos. If you have watched them, then upthrust is nothing for you. You know how to find the upthrust. So upthrust and relative density of that object. Find it. Find it and write in the comment. Let's see. Let's see. Solve it. Uh, I'm getting the answer. Upthrust is 10 GF and relative density is, I told you 50 and 60, right? 60, 50 and 60. So 60 by 10. Yeah. Uh, relative, yeah, correct. Correct. Relative density is 6 and upthrust is 10 GF. Correct. Yes, correct answer. All of you correct answer. I'm getting the answer. And those who are writing that relative density is 6 is to 1, 6 is to 1, don't write 6 is to 1, only write 6. Okay, only write 6, don't write 6 is to 1. Relative density is 6 and your upthrust is 10 GF. So where is the sum? Correct. Correct. Good. Very correct. Next question. All of you, next question you write. Yeah, this question is done. Correct. This question is done. Now, next question. Next question. The weight of an object in air. The weight of an object in air equal to 40 GF and weight of the same object in a liquid, weight of the same object in a liquid I said, not water, weight of the same object in a liquid equal to 25 GF. So I repeat from the beginning, the weight of an object in air equal to 40 GF and weight in a liquid is 25 GF. The relative density of that liquid, the relative density of that liquid means the liquid where that object immersed. Okay, the relative density of that liquid equal to 0.8. Okay, relative density of that liquid equal to 0.8. Fine. What is the relative density of that object? What is the relative density of that object? Find it. The formula already are given before. By using those formula only, one of those formula is required here. Now you find it out which formula is required here. Okay, find it and solve it and tell me answer here. I'm also solving it so that I can help you. Solve it and send me the answer. Let's see what is the answer. Yes, I can see. I can see. Don't write in ratio. Don't write in is to. Okay. I can see. I told you before also. Don't write in is to. Don't give is to. Relative density we do not display in is to format. We do not display in ratio format. Though it's a ratio, but relative density we do not give in ratio format. Don't write is to. Get it in decimal. Don't write in is to, write in decimal. Okay, write in decimal. Let me see what is the answer you are getting. Let me see. uh, few correct answers I'm getting, but since you all are getting in is to, don't get your calculation in is to. Don't, though the relative density is a ratio, but we do not write the answer in ratio format. Just you give in get the result in decimal format point. Okay, let's see the answers I'm getting. uh, yes, yes, Komal Agarwal. Then this Amrita Shah, I think he or she is using his mother's account. uh, yes, 2.13, then 2.13. Yes, 2.13 is the correct answer. 2.13. I've also solved it. See, 2.13 is the correct answer. This one. This. This is the correct answer. Relative density equal to weight in air by weight in air minus weight in liquid. This is the formula. Relative density equal to weight in air by weight in air minus weight in liquid into relative density of the liquid. Here I have written relative density of the liquid. Then you put the values and do the calculation. Okay, you will get 2.13. Understood? You will get 2.13. This is the correct answer. Correct answer. Okay, fine, fine. 2.13. So nobody will get their answer in ratio format. Don't get the result in ratio format. Okay, always you'll get in the decimal. Yes, understood? Next question. Next question. All of you write next question. Next question. Next question. Now, two questions I will say you that both the questions I will only solve because there a little concept is required. I want to give you that concept that small sums. I will tell you the small sums, but the concept is important. I'll tell you the solution. Okay, right. The weight of an object. The weight of an object in air. The weight of an object in air Oh, okay. Amrita Shah says, yes, sir. I am Samadrita Shah. Okay, Samadrita Shah. Okay, good. Fine, fine. Uh, right. Mm, the weight of an object in air is 45 GF. Okay, 45 GF. And weight in water is 35 GF. Fine. So I repeat, the weight of an object in air is 45 GF and weight in water is 35 GF. What is the volume of that liquid? Sorry, what is the volume of that object? What is the volume of that object? Okay, I will solve this sum for you. Listen, I will solve this sum for you. The sum is, what is the weight in the air? What is the weight of the object in air? The weight of the object in air is 45 GF. What is the weight of the object in water? 35 GF. Now, how much weight is reduced when you have immersed the object in water? How much weight is reduced? The weight reduced is 10 GF. Okay, 10 GF. So the volume of the object is 10 centimeter cube. Understood? The volume of the object is 10 centimeter cube. Okay, solve it. Solve it. Write in this way. The same way you write. Weight of the object in air equal to, weight of the object in air equal to 45 GF. Next line, weight of the object in water equal to 35 GF. In the next line, weight reduced in water, weight reduced in water equal to 10 GF. The next line you write, so the volume of the object equal to weight of, so the volume of the object equal to 10 centimeter cube. Okay, centimeter cube. Understood? Now next question. Next question. Next question you write. Next question is, the weight of an object in air, the weight of an object in air is 10 kgf. 10 kgf, not gf, kgf. Weight of an object in air is 10 kgf and in water is 8 kgf. 8 kgf. Okay, what is the weight in air? 10 kgf. What is the weight in water? 8 kgf. Find its volume. Find its volume. Now here, how much weight is reduced? How much weight is reduced in water? 2 kgf. Okay, how much weight is reduced in water? 2 kgf. So what is its volume? 2 meter cube, not centimeter cube. 2 meter cube. Okay, 2 meter cube. If the weight are given in GF, so here is the concept. When if the weight is given in GF, then volume is in centimeter cube. If the weight is given in kgf, then your volume should be in meter cube. Okay, 2 meter cube. So write accordingly. Don't forget. All of you, next question. Write the next question. An object, an object of weight, an object of weight 1.5 kgf, 1.5 kgf in air and 0.9 kgf in a liquid, in a liquid of density, in a liquid of density 1.2 into 10 to the power 3 kg per meter cube. I repeat, an object of weight, an object of weight 1.5 kgf, 1.5 kgf in air and 0.9 kgf in a liquid of density 1.2 into 10 to the power 3 kg per meter cube. Full stop. Find the relative density of that object. Find the relative density of that object. Find it and tell me the answer here. Tell me the answer here. Tell me the answer here. I am also solving for you. Now, where is my pen? Oh, it's here. Okay, I'm also solving for you. You also solve it. Okay. So, relative density of the solid. Relative density equal to Yes. What is the answer? Let's see. What is the answer you are getting? Relative density. Rishi Raj given me the answer. Piyush Agarwal also sent me the answer. And Samadrita asks, sir, which is this is which number? This is number 13. This is number 13 of this exercise. Uh, yeah, number 13 of the exercise. Number 13. Not from the example, from the exercise. Okay. Rishiraj has given the answer 3. Rishiraj again writing answer relative density 3. Okay. Piyush Agarwal answer is not correct. You should check it again. Relative density you have to find. Okay. Come on, come on, come on. Yes, relative density is 3. Yes, correct. Relative density of the object is 3. Simple formula. Relative density of the object you have to find. Relative density of the object equal to weight of the object in air by weight of the object in air minus weight of the object in liquid into relative density of the liquid. Okay, this formula which we have seen before. This formula. Relative density equal to weight in air minus weight in air minus weight in liquid into this. Okay. Um, so this much is the thing. Now all of you do one thing. All of you do one thing. I will say you start. That time all of you will start writing your name. Okay. All of you will start writing their name. I will say start. Got it? This relative density numericals are not finished yet. Okay. Relative density numericals are not finished yet. We will continue in our next class. Okay. Relative density numericals will continue in our next class. It's not finished yet. Okay. So all of you start writing your name. Start. Let's see. Start writing your name. All of you, come on, start writing your name and then you leave the class. Start writing your name, then you leave the class. I can see Agnik, Piyush, Susmita Sen, Ankur Paul, Ayush Sutradhar, Samriddha Shah, sorry, Samriddha Das, Rajdeep, Sanjog Karki, Riddhi Prasad, Komal Agarwal, Sagnik, Irfana Khatun, Tanisha, Anushka, Sikar, Aditya, Karan, Ankit Kumar Gupta, Nisha Chakravarti, Ritobroto, Rishiraj, Riddhi Agarwal, Khushi, Shreshi, Liza De, Catherine, Srija De, Sneha Prasad, Samadrita Shaha, then Salini Khalko, Darika Singh, then Sudhanshu Pradhan, Nayan Chandra Sarkar, Sneha Yadav, Srija De, Aditya Sharma, Salini Khalko, Yashraj Vitrikoti. Okay, Sneha Yadav. Fine. So I got your attendance. I can mark from here. Those who have made the comment, their name, I can take the attendance from there. So we are ending our class here. See you in the next class. Okay. Thank you. Thank you.